First, ice preserves history. On Earth, scientists drill deep into Antarctic ice sheets to pull out cores that hold bubbles of air from hundreds of thousands of years ago. Those bubbles reveal Earth's ancient climate. Now, imagine doing the same on a planet that has been frozen for billions of years. Its glaciers could hold the story of its atmosphere, its chemistry, and even the conditions of its star system at birth. In other words, ice is a time
We are
machine.
standing on the frozen
Second,
world.
ice planets may hide
Is this
life.
planet
On
truly
Europa
alive?
or Enceladus,
or just
liquid oceans
frozen
exist beneath
silence?
protective shells of ice. If life has ever formed there, the ice is shielding it from radiation and violent space weather. Finding even the simplest microbes would prove that life is not unique to Earth, that biology is a universal phenomenon. Third, ice means resources. Water is the most valuable substance in space exploration. It can be melted for drinking, split into oxygen to breathe, or hydrogen to make rocket fuel. In the future, icy moons or planets could serve as refueling stations, stepping stones that let us travel farther into the galaxy. Finally, ice planets stretch our imagination.
What is that?
They remind us that life and beauty don't just exist in warm, sunny environments. Rivers of methane on Titan, geysers on Enceladus, glaciers on Pluto. These are landscapes that defy our Earth-centered thinking. They challenge us to see the universe as far more diverse and creative than we ever imagined. So when scientists study ice planets, they aren't just cataloging distant rocks. They are unlocking clues about our past, our future, and the possibility that we are not alone. Frozen worlds are not empty. They are alive with potential. When we look at ice planets, it's easy to see only silence and cold. But step back, and they become something greater. Reminders, promises, and invitations. They are reminders that the universe is more creative than we imagine. Mountains of frozen water on Pluto, methane seas on Titan, geysers on Enceladus. These landscapes show us nature does not follow Earth's script. It writes its own in ice. They are promises that life may not be unique. Beneath the ice shells of Europa or hidden oceans of distant exoplanets, microbes could be swimming right now. If we discover them, we will know that biology is not a rare miracle, but a cosmic pattern. They are resources for the future. Ice can give us water, oxygen, even rocket fuel. Colonies on frozen worlds could one day use ice not as an obstacle, but as the very foundation of survival. And finally, they are invitations. Ice planets ask us to expand our imagination, to find beauty not only in warmth and light, but in darkness, stillness, and cold. They challenge us to step into the universe not as visitors, but as explorers ready to endure. So, do ice planets exist? Absolutely. We've seen them. We've measured them. And beyond our solar system, there may be billions more. The real question is, what will we do when we finally meet them? Will we explore, protect, or even call them home? The frozen universe is waiting, and in that silence, it may hold the answers not just to science, but to who we are. If Europa hides its secrets deep, Saturn's moon Enceladus displays them openly. Only 300 miles wide, it shoots geysers of water vapor into space from cracks near its south pole. NASA's Cassini spacecraft flew through these plumes and found water, hydrogen, and organic molecules, the ingredients of life itself. Enceladus may not only host an ocean, but also the chemistry to support biology. Standing there, you'd see fountains of water erupting into the blackness of space, majestic and haunting. Titan, Earth's alien mirror. Saturn's largest moon, Titan, is bigger than Mercury and the only moon with a thick atmosphere. Beneath its orange haze are rivers, lakes, and seas. Not of water, but of liquid methane and ethane. Titan has rain, erosion, and even deltas that resemble Earth's coastlines. In 2005, the Huygens probe landed on its surface, showing us a world that looks strangely familiar, yet utterly alien. Many scientists call Titan a prebiotic Earth, a place that might mirror the chemistry that gave rise to life on our planet billions of years ago. A frozen but living family. Together, these four worlds teach us that ice does not equal death. Pluto has glaciers that move. Europa hides oceans that may breathe. Enceladus sprays life's ingredients into the cosmos. Titan has a methane-based weather cycle. Each one is active, dynamic, and mysterious. The solar system proves the point. Frozen worlds are not the exception, but the rule. And if they are so common here, what might we find when we look beyond our sun? The icy worlds of Pluto, Europa, and Titan prove frozen planets exist in our own solar system. But what about beyond? Astronomers now believe ice planets may be among the most common worlds in the universe. We already see hints in our backyard. Uranus and Neptune are called ice giants. Their interiors packed with frozen water, methane, and ammonia under crushing pressures. If such giants exist here, it is almost certain other stars host similar frozen titans. Then, there are the exoplanets. In the past 3 decades, astronomers have confirmed over 5,000 of them. Many orbit so far from their stars that their surfaces are locked in perpetual ice. One, nicknamed Hoth after the Star Wars world, may reach -360 degrees Fahrenheit. Another, Kepler 62f, could be a frozen super-Earth with oceans hidden beneath miles of ice. And here's the twist. Ice doesn't just freeze, it protects. A thick shell can insulate liquid oceans below, just as we see on Europa or Enceladus. In those sealed oceans, life could quietly thrive, shielded from radiation, stable for billions of years. So, when we look beyond our sun, we no longer imagine only hot deserts or gas giants. The galaxy may be filled with frozen marbles, cold, dark, but perhaps alive. Ice planets are not rare curiosities. They could be the most common type of world in the cosmos. At first glance, the answer feels like a hard no. Temperatures on an ice planet can plunge so low that oxygen could freeze, steel would crack, and exposed skin would solidify in seconds. Walking outside without protection would be like stepping into instant death. But survival has always been humanity's story. With technology and adaptation, even the coldest worlds could be challenged. Imagine astronauts stepping onto an alien glacier. Their suits would be bulky, reinforced with heaters, recycling every drop of water and every breath of air. Their boots would dig spikes into the ice, each step echoing across a frozen silence. The greatest challenge wouldn't just be the cold, it would be energy. Far from a star, solar panels would be useless. Colonists would need nuclear or fusion reactors, or perhaps ways to drill into the crust to tap geothermal heat.
Oh my goodness!
Water, while abundant in frozen form, would need constant melting and purification. Greenhouses inside heated domes could recycle melted ice into irrigation, glowing with artificial light to grow the first crops on an alien snowball. Breathable air would also be scarce. Many ice planets may have atmospheres filled with methane or nitrogen, deadly to humans. That means sealed habitats, underground bases carved into ice, where thick layers protect colonists from radiation and storms. And yet, there is hope. Ice itself could become a resource, melted into water, split into oxygen to breathe, and hydrogen to fuel rockets. Colonies could one day glow under alien skies, linked by tunnels beneath glaciers, sustainable for decades. So, could we survive on an ice planet? With today's technology,
please stand down.
With tomorrow's, very likely. Humanity has endured Earth's own ice ages with fire and tools. Perhaps one day our descendants will endure a frozen exoplanet with reactors, domes, and determination. The cold would not be the end. It would be the next frontier. Ice planets may look like silent, frozen wastelands, but for science, they are priceless. Each one is like a natural archive, a laboratory, and perhaps even a mirror of our own planet's destiny. A world where the sky burns violet, the ground cracks like glass, and oceans lie buried under endless ice. This is not science fiction. This could be our universe's frozen truth. A world where the sky burns violet, the ground cracks like glass, and oceans lie buried under endless ice. This is not science fiction. This could be our universe's frozen truth. Close your eyes for a moment and picture this. You are standing on a world that looks nothing like Earth. The horizon stretches endlessly, but it's not forests or deserts. It's a frozen wasteland. The ground beneath your boots crunches like shattered glass, every step echoing across a vast plain of blue ice. Above you, the sky glows with strange colors, deep violet streaks and pale cyan mist, where sunlight struggles to break through frozen clouds. This is not an invention of science fiction. It's the scientific possibility of ice
the
planets.
aliens fall,
And the more we learn about the
humanity
cosmos,
will
the more
too.
likely it becomes that such frozen worlds exist, and may even be common. The question we're going to explore today is not only do ice planets exist, but also what do they mean for science, for life, and for us as humans?
I cannot hold
Over
on
the
much
next
longer.
30 minutes, think of this as a journey, half story, half science exploration. We will travel from the icy edges of our own solar system to exoplanets light years away, and finally to the question that stirs every explorer's heart. Could we one day survive on a world of eternal ice? So, buckle up.
Full
The
annihilation
frozen
protocol.
universe awaits. Before we go too far, let's ground ourselves. What exactly is an ice planet? At its simplest, an ice planet is a world dominated by frozen matter. On Earth, when we say ice, we usually mean frozen water. But in the deep cold of space, ice could mean many things. Water, methane, ammonia, carbon dioxide, even nitrogen or oxygen. Under the right conditions, materials that are gases on Earth can turn into solid ice blocks. Imagine standing on a cliff made entirely of frozen nitrogen. Imagine rivers of liquid methane that freeze overnight into sheets harder than stone. Imagine an atmosphere so cold that oxygen itself could snow down in crystals. These are not fantasies. They are consequences of physics and chemistry in extreme environments. If Earth were somehow cooled far below its current temperature, our oceans would lock into glaciers, our atmosphere might collapse into frozen layers, and our planet itself would become an ice world. But out in space, such conditions are natural. The further you move from a star, the colder it gets. Beyond a certain distance, what astronomers call the frost line, planets and moons can no longer hold liquid water on their surfaces. Instead, they become icy. What makes ice planets fascinating isn't only their appearance,
Now we
but
begin
the
again.
possibility of what lies beneath. Ice is not just cold, it's protective. A thick crust of frozen material can insulate what's below, trapping warmth from a planet's interior. That means that beneath the most lifeless frozen surface might be a hidden ocean. Liquid, dark, and potentially alive. So when scientists talk about ice planets, they're not imagining giant snowballs. They're thinking of dynamic worlds where cold shapes geology, chemistry, and maybe even biology in ways we are only beginning to
I
understand.
gave everything.
And the best part? We don't have to look to distant galaxies to find them. Our own solar system is filled with examples. If we want proof that ice worlds exist, we don't need to search distant galaxies. We already see them in our own solar system. They may not all be planets in the strict sense, but each of them reveals what frozen worlds can be. Pluto, the distant wanderer. Once called the ninth planet, Pluto now lives under the title of dwarf planet. But labels aside, it is breathtaking. Its surface is sculpted from nitrogen plains, mountains of solid water ice, and glaciers that appear to flow across the land. In 2015, NASA's New Horizons spacecraft showed us Pluto's heart-shaped plains and hazy atmosphere, proof
Perhaps
that
they are
even
not
a frozen
enemies.
world at negative 380 degrees Fahrenheit can remain geologically active.
Earth
Pluto
must
teaches
choose
us that even at the edge of
fear
sunlight, a
or
world
unity.
can breathe. Europa,
The choice
the
is
ocean
yours.
beneath Jupiter's moon. Europa looks like a cracked glass ball, but beneath its icy shell lies one of the greatest mysteries of all time, a hidden ocean. That ocean may contain more water than all of Earth's combined. Heated by Jupiter's gravity, it stays liquid in the darkness, and where there is water, there is always the possibility of life.
Our journey ends
Some
now,
dream of drilling through
but a new
Europa's
one
crust
begins for
and sending
humanity.
a robotic submarine into its alien sea. If microbes, or something more, exist there, it would be the most important discovery in human history. Enceladus, the cryovolcanic moon.